Welcome to the Explainer. Have you ever just stopped and wondered about the math behind possibilities? Like, how do you figure out all the different ways something can happen without having to list every single one? Well, the secret is in two really cool ideas: permutations and combinations.
Okay, let's just dive right in with a feeling we all know, that sinking feeling in your gut. You're standing there with your suitcase, and you absolutely cannot remember the three-digit code. You start guessing, but how many possibilities are you really up against? It can feel like an infinite number.
So, to figure out a big problem like that suitcase lock, we need to build up our mental tools. And the best way to do that is to start with something way simpler. So forget the lock for a second. Let's think about your wardrobe.
Here's our simple little puzzle. Let's say Mohan has 3 pairs of pants and 2 shirts. It's not a huge wardrobe, but how many different unique outfits can he actually create from just those items?
Now sure, we could solve this the slow way. We could literally list out every single option. Take the first pair of pants, match it with shirt 1, then shirt 2, then take the second pair of pants. You get the idea. This table shows you exactly that. It works, but man, it's slow. There has to be a faster way, right?
And here is that faster way, our first big idea. For each of the 3 pairs of pants Mohan could choose, he has 2 different choices for a shirt. So we can just multiply those choices together. 3 times 2 gives us 6 total outfits. See? Simple.
That little trick we just did, the multiplication thing, it's not just a trick. It's actually a really powerful mathematical rule that lets us count a huge number of things without breaking a sweat. It's called the multiplication principle. So here's the official definition. It sounds a little formal, I know, but it's exactly what we just did with the clothes. Picking the pants was our first event, which could happen in m ways, that was 3. Picking the shirt was the second event with n ways, that was 2. The total number of outfits is just m times n. This principle is basically our superpower for everything we're about to do.
Okay, let's put this new superpower to the test with something a little bigger. How many different 4-letter arrangements can we make from the letters in the word rose? And the key rule here is we can't repeat any letters. A good way to think about this is to imagine we have 4 empty slots to fill. So, let's look at that first empty slot. It's pretty simple, right? We have 4 letters to pick from. We can use the R, the O, the S, or the E. 4 choices.
But here's where it gets interesting. Once we've put a letter in that first spot, let's say we picked R, it's now used up. We can't use it again. That means for our second slot, the number of choices has dropped from 4 down to 3.
And you can probably see the pattern here. We've now used 2 letters, maybe R and O. So for that third slot, we're left with only 2 possible choices.
And for that very last spot, well, with 3 letters already placed, there's only 1 left. Our choice is basically made for us.
Okay, now we bring back our multiplication superpower. We just multiply the number of choices for each spot. 4 choices for the first, times 3 for the second, times 2 for the third, times 1 for the very last one. And that gives us a grand total of 24 unique arrangements.
So this method works great, but imagine if we were arranging, say, 10 letters instead of just 4. Writing out 10 times 9 times 8 times 7, well, that would get really annoying really fast. And you've probably guessed it, math has a much more elegant way to write this.
And here it is. It's called factorial notation, and it's just an exclamation point. So when you see n factorial, or n with an exclamation point, it just means you multiply n by every single whole number below it all the way down to 1. So that calculation we just did, 4 times 3 times 2 times 1, can be written way more simply as just 4.
Let's just see it in action real quick with 5 factorial. All it means is you expand it out. 5 times 4 times 3 times 2 times 1. Punch that into a calculator and you get 120. It's a fantastic little shortcut, isn't it?
So this whole process of arranging things where the sequence is important, it has a name. It's called a permutation. And this brings us to a really critical question you have to ask yourself when you're counting possibilities. Does the order actually matter?
With the permutation, order is everything. Our rose example was a perfect permutation. The word RESO is a totally different arrangement from ROSE, even though they use the exact same letters. Every single unique sequence counts as a brand new possibility.
Okay, but what if the order doesn't matter at all? What if you're just picking a group of things, and you couldn't care less about the sequence you pick them in? Well, that brings us to our second big idea: combinations.
A combination is just about the group you end up with. Think of it like this. If you're picking players for a team, and you pick Anne, and then you pick Bob, that's the exact same team as picking Bob and then picking Anne. The final group is identical. That's the heart of a combination.
All right, if you only remember one thing from all of this, make it this slide right here. To figure out how to count possibilities, you have to ask one simple question. Does the order matter? If the answer is yes, you're dealing with a permutation. A lock code of 789 is completely different from 987. But if the answer is no, it's a combination. A pizza with pepperoni and mushrooms is the same pizza no matter which one you ask for first. It's all about the final group.
Okay, we've moved pretty fast and covered a lot of ground, so let's just take a breath and recap the powerful new tools you now have in your mental toolkit to solve these kinds of problems.
So here it is, your new toolkit. You've got the multiplication principle as your base for any problem with sequential steps. You've got factorials as your awesome shortcut for writing those long multiplications. And then you have the big decision maker. Is it a permutation where order is critical? Or is it a combination where you're just picking a group?
So I'll leave you with a final question to chew on. In a big lottery, you have to pick, say, 6 winning numbers out of 49. To get the winning ticket, do you just have to have the right numbers, or do you have to have them in the exact order they were drawn? To figure out your real odds of winning, you'd have to know the answer. Is it a permutation or a combination? Thanks for tuning in.